Fantastic. Let's get started. Hello again, and welcome to today's webinar using GPT-4o to accelerate your model development. Got a really packed agenda today, and it's a 30-minute session, so let's jump into it. We'll start off with some introductions. So firstly, I will be your host today. My name is Oscar. I'm one of the ML Solutions engineers over here at Encord. So effectively, I get customers familiar with the product, identify cool use cases, and help them get up to speed with how to accelerate their data pipelines. And I'm joined here today with Frederik, who's our ML lead. Frederik, would you like to introduce yourself?
Yeah. Hey, Oscar. Thanks for having me. Happy Friday. Yeah, I'm Frederik. I'm the machine learning lead at Encord. I have spent quite a lot of time looking at these VFMs recently, and especially this week, it's been very busy with, GPT-4 Omni landing. Claude 3 Opus was finally made available to the European market, and Gemini 1.5 Flash also came out. So we've had a lot of stuff to do, and today we will be diving more into GPT-4o. So I'm super excited to be here. Thanks for having me again.
Thanks, Frederik. Yeah, thanks for joining, and a warm welcome to everyone joining from everyone at Encord. Fantastic. So let's take a look at this agenda. So this was a impromptu webinar because it's been a really busy week in the VLM or VFM space. And so we wanted to respond to the release of GPT-4o with a discussion and application of OpenAI's latest offering. So we'll start off by discussing, what you get with GPT-4 Omni and the pros and cons of it versus other models. And then we'll look at a live application of how you can actually use this within the Encord platform and to accelerate your annotation process. Really excited to dig in today. So shall we get started? Frederik, there has been a lot of hype this week. You talked about it. That's been OpenAI are really good at curating a kind of mystique around their product. And I think they get people talking, people are interested in the politics of the board. And I know there's been some changes there as well this week. Catch us up to speed. GPT-4o, what do we need to know?
Yes, that's. I think that was a really good introduction to the entire hype cycle. A couple of weeks ago, there was this LLM open leaderboard where you can upload your models and people can anonymously evaluate them by interacting with two models at the same time. And they write a query and then see two different responses, and then they vote which one is the better one. And a couple of weeks ago, a new model appeared, and that was called GPT-2. And that was already sort of spiking a lot of interest. Where did this model come from? Is it really from OpenAI? That created a lot of hype. And so a couple of hours later, it disappeared. And people were like, I don't know if you follow Twitter, but Twitter was just like glowing red of people talking about it. It reappears, and it's really confirmed that this was quite a good model in that sort of evaluation. Now, then the hype slows down a little bit, and then we are told that they will release something Monday, this Monday. And so Monday they have this big release of GPT-4 Omni. And it's a really cool model. We'll get into that. But then already the day after, the Google team, they release Gemini 1.5 Flash. A couple of hours after that, as you mentioned, Ilya from basically the top of AI engineering and machine learning, he decides to leave. So there's been a lot of speculations around, is it really, how can that timing be just a couple of hours after Google announcement? So yeah, very very exciting. Things are moving fast. It's quite fun to follow.
Absolutely, yes, and excited to have everyone here joining the conversation because things are moving quickly, and we're hoping to respond. Fantastic. So let's dig into GPT-4o now a bit more. This was released on Monday after a mysterious kind of pre-announcement. Come on Monday to join. And we get this. We've had GPT-4, we've had GPT-4v, and now we have this Omni version. So what do we get with that? What functionally is different here?
Yes, it's the exact right question. What is different from a technical standpoint is how it was trained, it seems. So we haven't seen the technical report quite yet. But one of the things that seems very clear is that it's been trained end to end with multi-modality. So what does that mean? Well, it means that it's learned one model to do everything basically. So one model that understands audio, comprehends it and generates audio again, for example, or the same model does video as input, understands it and generates audio, or video as input and generates text. And it's been trained end to end. So what happened previously, if you had the OpenAI app on your phone, you could do sort of voice conversations with ChatGPT. And the way it would do that was by transcribing with Whisper, then running GPT under the hood, and then re-translating from the text output from ChatGPT to audio again. And now it seems to be something that happens directly. And that have a bunch of different nice upsides. One of them is latency, and that's probably the most the valuable one here, which we'll also be looking a bit at. And so what does it mean? Well, it means that prior to this release, when you were doing these sort of voice-like conversations, you would be telling something and you would be waiting maybe 3 or 5 seconds, as the left column in GPT-4 illustrates in the plot to the right, before you would get a response. Now the response time is a quarter of a second. So it's much faster and it seems much more natural to be discussing with the agent. There's one caveat though. If you are using the API, you cannot really use these multimodal interactions just yet, at least. So you can upload images and you can upload text, but you cannot do this voice to voice, for example, or video to voice, or like these kind of more advanced interactions quite yet. It seems like it will be coming.
That's really interesting. Yes. Okay. So that's where this Omni comes into it. So rather than having a multimodal to text to multimodal model, this is a kind of true multimodal functionality. And with that, we see this improved inference time and reduced latency. And yeah, it'll be interesting to see how that API interaction develops as well with time. I know that's something we're going to dig into a little bit in this session. Mm-hmm. Excellent. So now we've kind of looked at what it is and how it works. Let's do a quick comparison to other VFMs out there.
Yeah. So if we look at this plot, what we will see is that the right bars, the left bars that are red, they are from this new model. So they actually released 2 models essentially. They have GPT-4o and GPT-4 Turbo. And so what it seems to me is that they don't really improve much in terms of accuracy. Maybe if you look at math questions, they do better, but it's not like significant improvements in terms of accuracy. However, you get a comparable performance at maybe what is that, a 12x improvement in speed. So that is very, very nice. So if I am a data ops guy that's trying to manage my data and want to analyze a lot of data, this means a lot, right? I can, instead of spending 10 days analyzing my data, now I can do it in within a day. So that's extremely helpful to all of us out there doing data extraction from visual inputs. And also what we're going to sort of look at today.
Very cool. Yeah, that makes a lot of sense, that a few % difference in the kind of actual output quality is quite hard to quantify, I suppose, with these generative models. But the 12x improvement in inference time, you can see that that's going to give you a tangible gain versus some of the competitors for specific use cases. That's really interesting.
Yeah, and it also, of course, applies to if you're building some sort of an app which integrates with this tool, then you can also make a much more seamless interaction, right? It's not just OpenAI that can produce an app now that's more seamless. It will also eventually be you as a sort of third party.
Very cool. Yeah, that kind of leads us on nicely to the practical part of the session. So now we've discussed the kind of lore behind GPT-4o and looked at what it is and how good it is. Let's actually put it put it to use. Let's try it. So today we're going to get a live demonstration from Frederik where we're going to see a custom agent. And for those of you who are more interested in a kind of in-depth look at VFMs and how these are used in industry and things, then I would recommend you check out our last webinar on Google Gemini, which was an hour-length one, and we dug into that in a bit more detail. And we also showed how to set up one of these custom agents within Encord. And effectively, what these custom agents are an ability to go into the annotation platform and then call your own action using a cloud function and the Encord SDK to trigger this response, bring it back into your label editor. And that's something that we've done with Google Gemini already. And now we're going to be doing with GPT-4o today. I don't know if you wanted to add anything there, Frederik.
No, I mean, that's exactly what you do. You can, as a user of the Encord system, you can provide an external URL, and you can trigger that URL with the information about what you're looking at right now in the label editor. And then that URL is basically responsible of doing whatever you want, right? So it could be adding labels to an image, as we're going to see today, but it could also be validating labels already there, or, you know, adding a comment, or whatever you could think of. You probably have your own idea about what it might be useful for, right?
Absolutely. So if you want to start sharing your screen and take us to the label editor. So Frederik's going to flash up the Encord label editor and a couple of examples that we've been looking at, and we'll see these agents. And so some of these can be things like any OCR models from a geometry, or we have a way to like tweak bounding boxes that are already existing. And then we have these VFMs in there as well. So Frederik, now we're in the label editor. We can see our different types of class on the left and our image on the right. And so do you want to give us an insight as to what we're looking at with these agents?
Yeah, it's exactly as you said. What we have here is a labeling task with 4 different sub-label tasks, I suppose. One would be just getting an image summary. What do we see in this image? Another one could be a classification task where it's conditioned on your answers, in the sense that first you're going to be asked, are there any animals in this image? And if you answer yes, excuse me, then you will get sub-questions of what type of animal is it? You will have to answer if it's a bird. Then you will have to also provide a description of the bird. So that's another one. So sort of nested ontologies. And then we have one with some checkboxes. And finally, we have a transcription. So if there's any text in the image, we would like a transcription of the text as well. So this is just one ontology we came up with here. It's not sort of tailored for this particular demo, except from the fact that it's of course supposed to fit to the data, or like to be appropriate for the data. And so what will happen now when I click this GPT-4o custom agent is that it will send to our agent that we are looking at this specific image right now. We are on this project, and this is the ontology. And then what the agent will do is it'll translate that information to a prompt or a query to GPT-4o, and it will get a response, pass the response, and then translate it into our Encord labels. So that's what happens. And actually now, while we're demoing, you could maybe think of a good thing we might want to put into this ontology to see that I'm not cheating. Right, so anyway, here we got the response. I think it was quite fast. Actually, much of the overhead is from just communication. So sending the image or fetching the image from the agent and then sending it from there to OpenAI. So that's kind of a 2-step process there that needs to happen. Okay, so we got the... Oh, sorry.
I'll just jump in for anyone who's unfamiliar, maybe hasn't seen our annotation platform, or is maybe and is wondering why we have these nested ontologies. So the structure that Frederik just showed is this ability to capture structured information, which improves your model output while managing to maintain the high level of information that you capture in free text. So that's this advantage. And if you're interested in how to set this up, then Frederik talked through how we can map these using pedantic models in the in our last Google Gemini webinar. So if you're interested in getting that notebook, I think we're going to put one out for GPT-4o as well after this. Then definitely get in touch. Sorry, Frederik, back to you.
Yes, no, it's completely right. And one of the things that is hard typically about these VFMs is that you typically get unstructured outputs, right? If you ask for these things, it might answer the right thing, but you as a human kind of need to read it before you can extract the information. And so if you go very structured in the way you approach the problem, then you can also get structured responses. And that's what we sort of leverage here. Yeah, so let's just have a quick look at what we got. So we got an image summary, captures 2 birds, so on and so forth. It's probably right. I'm not a biologist, so I can't confirm all of the details there. But what I really want to show you guys is the sort of the ability to do these conditional answers. So based on the condition that the answer from GPT was yes to the animal question, then we would ask, is it a bird? And then we would get the detailed description. Had it been
Do you
a
want to
dog,
open up the classification to make that clear?
yes.
Like edit
Yes,
the classification. Yeah, absolutely. Nice.
Yeah, exactly.
So now we can
yeah,
see that
so this is
conditional.
kind of the flow it went through. So had we answered horse here, we would not be asked about the detailed description. And had we answered no, we would not be asked to answer the other nested properties.
Very cool. And we're going to look
Right.
at another example on a different image. Is that right?
Yes. Let's do that. So I have lined up another one here, kind of a shameless plug. I grabbed our landing page as it is today, just for the sake of having this image transcription. Now, one thing you will notice in the way I structure the ontology is that I kind of used it as a prompt to GPT, in the sense that I said, please break it down in sections of paragraph tags. And that's kind of somewhat an underspecified prompt, but still, just because GPT saw so much data from the internet, it's probably, I'm guessing now, probably going to follow HTML. And so you get an image summary still, something about how the image is looking, and you get the transcriptions where everything is transcribed in these paragraph texts. So I think that's another really cool application, right? You can extract information from your images, not just by visual content in a sort of semantic sense, but also from text.
That's very cool. And I think a part of the power of this, right, is the ability to, as we change this ontology, we can change this agent. I've seen we've had something in on the Q&A as well. We can change the ontology, and then the GPT will be able to map its response and kind of take its prompt from the ontology. So if anyone from the audience will open this up, has anything they would like to see for either of these 2 images, I don't know, Frederik, maybe you can show, we can change ontology live and maybe add something in to like count the number of birds. And then we could do something cool with the text, maybe ask it to infer some information from the text rather than just transcribing. So this is kind of an advantage beyond traditional OCR. This is why you would use these foundation models, because they can actually interpret your text, right?
Yeah, exactly. Spawned in with one number only. Okay. So this is going to be a text field where it's enabled to set the text to the number of animals. And then the second one was what? Summarize. So please summarize. You always need to be kind, right? Text in the image. That's also going to be a text field.
So this is us editing our labeling schema now, right?
Yes. So now if I come back here and I refresh the page, I should see these 2 new questions. How many animals? And summarize, please, the text in the image. All right. So let's see. Let's trigger this one. Maybe I can trigger this already. Guess I need to do a refresh to not break anything. There we go. Okay. Maybe it's because I left the editor. Nope. Sometimes GPT fails to respond in proper JSON, structured JSON, and then we get these issues where we don't see anything. And then typically you can query it again. So we didn't sort of include the retry functionality by default, but
Another advantage of the fast inference time, right? It's not too onerous to call it again.
Yes. Okay, so 2 animals in the image. There's no text in the image. Okay. And for the second one, see if it was just not refreshed. Oh. Or if it actually failed. Maybe I should.
Very cool. So we've had our birds counted.
Nope.
So
doesn't like it.
Doesn't like it. Maybe we could try one of the different agents. We could try
one of the other ones.
Claude or
Claude, maybe.
This is the fun of live demonstration. In the meantime, we've had a question saying, do we have this feature currently on the Encord platform? Yes, this is definitely something that is available. So this is something you can build your own agent, and also we're looking at building out the Encord agents as well for customers to use too. We've also had the question. Oh, we'll come back to that one moment. Frederik, I can see we've got a response. Which agent responded here?
So it was Claude Opus that helped us out here. So now we got, and it also does OCR, fortunately. So now we got a response with a proper summary that Encord is a data development platform, provides tools for AI, yada yada. So
very
cool.
nice.
So, yep. And in terms of the question about bounding boxes, for example, you could think of this as if you have a model already. One of the models that you could use off the shelf is like YOLO World, which is just an open class object detector. So you can type in "I want dog," and then it's gonna find dogs for you. At least it's gonna do its best to do so. And you could power that on your own backend, use your own custom agent, and that would give you that functionality right there in the editor. That's like one example of how you could solve that problem. It's really hard to get GPT or Claude or Gemini to actually do object detection. They don't like that.
Very cool. And I suppose if now, if you want, I can share again, because I think we had a few pre-submitted questions. In the meantime, can answer, do you allow me to filter, organize, and label images using unsupervised methods like KNN, L1, L2 with clip, or similar embeddings?
Yeah, that's a good. It's actually almost my favorite question, I would say. And the reason why we're both smiling is because we have a tool called Encord Active that does exactly that. So it allows you to curate and filter and search your data based on clip embeddings. And you can do nearest neighbor search. You can visualize everything in 2D embeddings. Yeah, so exactly that is also available in the platform for sure.
Fantastic. And I think now we can just take a look at these pre-submitted questions. So if there are any more, then please submit them through the chat. But to start with, how do you adapt the semantic search using Clip and ChatGPT for custom domains like industrial inspection?
Yeah, and that's a really good question. So there are a bunch of ways in which you can do that. First of all, what you could do is you could start, if you're doing semantic search, so that is, for example, searching with image similarity search or with natural language search, then the first thing you can do to remove noise is you can average over multiple queries. So instead of searching with one image, you could search with 5, average the embeddings, and then do similarity search. That tends to work better. That's one idea. Another one is you could, of course, also, one thing we have that's a bit sort of disappointing is that it's Okay, let me take one step back. LLMs, they are really good at something called in-context learning. And that is, if you give ChatGPT, for example, 10 examples of something you like, let's say you're trying to prepare the next, world awarding joke, and you show GPT the 10 best jokes you know, then it'll actually provide a better joke when you ask for the 11th joke. So one thing that is really disappointing is that GPT doesn't, and most of these VLMs, chat-based, they don't really improve when you show them multiple images. So very disappointing. But one thing I have seen work quite well actually is using these VLMs to transcribe or like to describe the images, and then doing a search on the description of the image instead. That actually tend to work better. So that's a trick you can do there. And then of course the next step, if that's not enough for you, would be some sort of fine tuning. And it kind of relates to the third question. So maybe we get back to it there.
Very cool. Yeah, that makes sense for these specific domains as well. This ability to kind of learn in context. I think even something that the UI for ChatGPT had something where you can set these memories now, where you can give it context about yourself such that it remembers and applies it to all future contexts. So you can see why that would be helpful for these custom domains when you can say, like, yeah, I'm interested in industrial inspection or any other logistics pieces or sports or advertising or medical, whatever it is that your domain is. That's really cool. And that kind of leads quite nicely onto the next case. We've definitely talked before about the ability to use VLMs to extract this key information from large quantities of data and reduce the kind of human load required for that. What are some of the key business use cases that you see for VLMs in the short and long term?
So definitely in the short term, it's stuff like data extraction. Of course, chatbots and stuff like that are also nice. That can also be used for insurance, right? You could have these chatbots that understand vision. You could do that today and understands how to inspect, car damages or stuff like that. So these kind of applications where it's not too time critical and it doesn't require planning. So that kind of leads me into the longer term future. I think that planning is going to be the next that's going to happen. First for LLMs, for plain text models, and very, very shortly after, it will follow with multimodal models. That has a bunch of sort of downstream applications, right? One good example is robots. Probably these robots, and we have seen it already from, Tesla has a robot lab that does stuff like that, and there are a bunch of others. So that's sort of the next step, I would say, and we will probably see stuff like these AI clips evolve even more and actually be useful at some point.
Very cool. Very, very exciting. I know that the multi-modality is definitely something that we're super excited about. And lastly, so we've kind of touched on the different ways that we can look at embeddings, and then we've obviously been discussing these language generators as we saw in our demonstration. So we've got these two different styles of models. Have you come across anything? And I suppose our Omni model that we've been talking about today could be a version of this. Anything that works well for both generation and multimodal retrieval.
Yeah, so maybe 2 sentences on the context here. Most of these sort of text generation models, they have a one of the other types of models. So one of these models you can use for search, for similarity search, for example, or semantic search, baked into them just as a way of communicating with vision. So the question now is, is there a setup in which I can use that thing inside the stomach of the VFM to also do semantic searching while still having all the capabilities of the larger sort of text generating model? And that is a really good question. And this is yet another sort of subsection of the AI and LLM field that moves really, really quickly. 2 things I want to highlight here is that if you want to have really small models, then actually this week as well, the Google team, they revealed or released a small model called Harley Gemma. And that model is open source and it's been optimized for fine tuning. is essentially not meant to be used as is. It's meant to be tuned to a specific problem. And it's only, I think, 3 billion parameters. So it's something you can actually do on Google Colab with the T4 GPU. So that's one possibility. So you fine tune that, and probably you can get both, at least if you are a bit, creative with the way you train it. And the second thing I want to mention is at CVPR, just shy of a month from now, there's another model called VL Intern that was quite a nice release of publications, because they actually released 2 publications, one technical report for the image backbone and one for the LLM. So that means that they actually evaluated both of them. So that's probably a good place to look if you're okay with a lot of parameters and hosting big models. Yeah.
Very exciting. Yeah, that's fun to hear about kind of what's happening now and then future releases as well. That's great. We are 2 minutes over, so I think we'll round things up. Thank you, Frederik, so much for your time today. We're so lucky to have you in on these sessions. And thanks everyone for joining. And we will be announcing our next webinar very shortly, so stay tuned for that. And on behalf of Encord, have a lovely weekend. Thanks everyone. Bye.
Thank you, Oscar.